we're going to do example 4 from 7.2, and we're going to be using the famed scale factor triangle. And we're going to use it to fill in the chart where you're given the length of the original and perhaps the length of the copy and have to find the scale factor. Or anyway, you're given two of these three elements and you have to find the third. So let's go back to the triangle and just try to remember how to interpret it. So scale factor, okay? So you write down scale factor, and how you're supposed to perceive this is that some part of the copy or the scale diagram. I call it a scale diagram, the package calls it a copy. Let's say it's the length of a rectangle. Okay, so that's the key thing. The C doesn't technically stand for the copy, it stands for some dimension of the copy. So, and you see the C's on top, and there's this line here, which is supposed to mean division. And then you divide the length of some part of the copy by the corresponding length found on the original. So it's in the case of the length of a rectangle, it would be you'd be dividing the length of the copy of the rectangle by the corresponding length of the original. Okay? So what we want to do here is first address the chart questions where we do not know the scale factor. So if you look at the very first question, we are given the length of the original and we're given the length of the copy. So if we come over here, we're supposed to take the original, the copy, and divide it by some part on the original. So if we come over here, copy is 24 and the length of the original is 12. So 24 divided by 12, the scale factor is 2. Okay? All right. Now let's see if we can, I'm going through my notes here. Okay. So let's try to find another one. Let's go down here where we've got 25 centimeters. The 25 centimeters is the length of the original, so we're going to put that on the bottom. And the length of the copy is 5, so we're going to put that on the top. Just remember, you put the original on the top, you put the copy on top, and the copy in this case is 25, and the original is 5. And we do a little bit of math over here. You get 5/25. And there's your scale factor. And again, 5 is called the factor of enlargement. It is okay to express this as a decimal, so you can call it, you can say the scale factor is 0.2 because 1/5 is equal to 2/10. And 0.2 is obviously 2/10 as well. So in this case, the scale factor is 1/5. And there's, I'm going to put the answer right here, 1/5. And that's the only one, those are the only two where we had to find the scale factor. So let's take a look at this question here. Well, this question, we are given, the second one here, we're given the length of the original and we're given the scale factor. So we're looking for the length of the copy. So let's take a look over here. This is how you interpret this triangle. The idea is that this is a multiplication sign. So the copy is equal to scale factor times some part on the original. So in other words, again, I always like to use rectangles, it's the easiest, but some length on the copy is equal to the scale factor times the corresponding length on the original. So we just go back here and we've got a scale factor of 4 the original is 9 centimeters, so we just multiply 4 by 9 and we get 36 centimeters. And of course that makes sense because the scale factor greater than 1 means an enlargement, and in this case it's 4 times larger, and 36 is 4 times as large as 9. So let's just see if we have another example of this. Yes, we do. Down here we are given an original length of 14.7 centimeters. Let me just fix that a little bit here. 14.7. And our scale factor is 0.6 or 6/10. So again, since we're looking for the length of the copy here in the middle, we go back and we look at our formula. C is scale factor times, that vertical line means times, some part of the original. So here the original is 14.7. The scale factor is 0.6. That's just above half. So when we multiply, we should expect a number that's just about a little bit more than half of 14.7. And that's exactly what we get. We get 8.82. And that should make sense because 0.6 is less than 1, and any scale factor less than 1 means a reduction. And since 14.7 is some length on the original, we're reducing it, we should end up with a smaller number than 14.7, and we do with 8.82. And that leaves us with our last type of problem, where we are given the length of the copy here. There's another one down here, and we're given the scale factor here and here. So let's take a look, because we're looking for the length of the original, and this is how you interpret this, okay? The length of the original, O, is equal to the corresponding length on the copy, and then this line right here means division, divided by the scale factor. So that's how you, again, interpret it. You've got a scale factor is copy divided by original. Copy is scale factor times original. And now we're looking for two problems where the original is equal to the copy divided by the scale factor. So let's go ahead and take 48. That's the length of the copy. And we know that 1.5 is greater than 1. So when we divide by 1.48 by 1.5, we will get a number that is smaller than 48. And it should be because the 48 is the length of the copy, and the copy is 1.5 times larger than the original. So if you take 48 and divide it by 1.5, you will get 32, which is perfect because 48 is 1.5 times greater than 32. And again, looking at finally at the last formula, if you want the length of a particular part of the original, you take the length of the copy and you divide it by the scale factor. So in this case, you can see the scale factor is 1/10. So the length of the copy is going to be 1/10 of the length of the original. So if you're on top of your game, you can probably do this without dividing, but and come up with the fact that the length of the original is 100. But if you did divide 10 by decimal 1, because you're following this formula, original is equal to the copy length divided by the scale factor, you would come up with 100 centimeters. And that, if you apply a scale factor of 1/10 to 100 centimeters, you will end up with a new length of 10 centimeters. So again, I know this triangle is not for everybody, but for some people they find it pretty handy. So again, just to sum up, if you're looking for the scale factor, you take some length of the copy and you divide it by the corresponding length found on the original. If you want to find out the length of the copy or some part of the copy, you take the scale factor and you multiply it. That vertical line means multiplication. You multiply it by the corresponding part on the original. And finally, if you want the original, some length on the original, you take the corresponding length on the copy and you divide it by the scale factor. And that's how you use the scale factor triangle. Talk to you later.